Very good morning, everyone. This is Jason Raju, and in the today's class, we would like to discuss regarding the robotics programming languages, which are utilized for controlling the different links and different actuators that are being assisted with respect to the robot. The basic contents, if you've been gone to it, we'll be learning the basic concepts in the robotics and how the programming is being taken care for guiding the overall actuators need to drive within the robot, and indeed to characterize this, what's the economical factor that is existing beyond the robotics functioning. We'll be having a detailed look and some of the applications that is which you have been utilizing in the industrial basis and for the manufacturing, and even for in the medical fields and the different medical fields and engineering fields and research and development technology and different domestical aspects also. Even we'll be having a look over here, and later on we'll be moving for the overall conclusion, why this robotics plays a major important role, and beyond that, irrespective of the external reference, how internally it is being operating as per the programming device. And with it, in the next class, further classes will be discussing regarding this programmable logical controllers also, or else this artificial intelligence impartation with respect to this robotics also, even that we will be looking after in the for the classes. The moving on to the basic introduction, we all aware of this, that the robot is a reprogrammable multifunctional manipulator designed to move the material, parts, tools, or the specified devices through a variable programmed motions for performance of a variety of tasks. So the task may be of the task may be of the working environment, that is fitting sessions or else the modeling sessions or the spraying sessions, which are utilized in the industrial characterizations. We will be having a discussion to it. Coming to the point of this programming, we are having three different methodologies existing for the input of this programming. The first one, it is an manual teaching method. Second one is an lead through teaching method. Third one, it is an programming languages. Coming to the first characterization, manual teaching. In the case of this manual teaching, the point to point applications will be characterized. So point to point applications, in the sense, the coordinate access will be specified from the point 1 to the point number 2. There is Cartesian coordinate systems. So as we all are aware of that, we are having four different types of coordinate units. That's an first one, it is an Cartesian coordinate systems. Next one, it is an the cylindrical coordinate system, articulated system, and next the circular interpolation system. So by this, we'll be utilizing the specification of points. So hence, in the point specifications, we'll be specifying three different coordinates, that is x coordinate, y coordinate, and then the z coordinate. So by that, the robot will traverse its motion and characterizing the path for reaching the destination point. So that is a manual teaching. So in the manual teaching, we'll be guiding it externally by an separate driver. So driver, in the sense, we will be utilizing here the external person who is operating on that particular characterization. For this, the best example, it is an lathe machine working. So indeed, to characterize a particular diametrical, indeed to follow the particular diametrical axis internally. So initially it will be existing of an 50 mm of diameter. I will have to go later on concise it towards n 45 or else the 40, and 10 mm need to be decreased. For that, 2 to mm will be getting minuted with respect to the process commencement in the lathe machine process. Second one, it is an lead through teaching. So lead through teaching, and here it is a continuous path programming which is utilized. That is continuous in the sense, here also the path will be specified indeed to connect with respect to n number of points as we have been discussed in the path planning. Next one, it is a robot simulator. So simulator also will be tracing n number of paths that are being existing, and among that, what is the best path will be having a decision. taking with respect to the time basis. So which path will be occupying the least time bound, that will be selected as an optimum traceable point, which will be commencing the work from starting point to the ending point. Simultaneously, one of the basic advantages regarding this lead through teaching is an direct programming, but also having some of the disadvantages of the direct programming. Maybe the traverse may be getting discomforted, or else the tilting towards the left or right cannot be monitored by this lead through teaching. There is a greater disadvantage in the case of this lead through programming. And coming to the conditions here, the motion will be recorded and played back in the same manner, but unidirectional motions also can be played. So this is a greater disadvantage because these recordings and same vice versa, if you have been followed for the next commencement of activity also, it's a greater drawback that changes the dimensional accuracies irrespective of the desired dimensional accuracies on the work part when we have been considered in the industrial working strategy. Second one, it is very much impossible to achieve exact required velocity. So as per the velocity we have been considered may not be obtained because it is not an closed loop control system, and memory size is required to store the data. Through the lead through program, always the programs will be getting changed simultaneously, and the program also will be getting deferred even in the dimensions of preference. And coming to the next point, investment in the simulator is required. So that is an additional economy when compared with respect to the lead through programming. And coming to the programming languages, third one, it is programming languages. First we are having this a machine language, next one a variable assembly language, and a manufacturing language. Fourth one, it is an robot programming language. Here initially it came into an existence with respect to an generation strategy wise. So first programming and furtherly the modifications has been done for an enhancement of the programming range. Later on, some of the modifications or additional technologies has been imparted in the existing program for a better functioning of the robot within the less timings, manufacturing more number of components as an output. It leads to an less time commencement and high efficiency obtaining at the output range. So here we have classified these robotics languages into three different categories. First one is an first generation language, second generation language, next one world modeling and task oriented object level language. Coming to the first one, there is a first generation language. So the offline programming. So offline programming is used in the combination of teach print. So here offline programming in the sense nothing but coding format will be given to the machinery. So that is also through an punched devices. So punched devices will be utilizing in as we have been verified in our numerical control programming also. So numerical control program sense in the sense the punched device which will be having 2.5 inches will be fed to the machinery, and whatever the program that you have been given will be getting read from that punched tape to the programming language language, and upon that particular reading the instructions will be getting on monitored in the machinery device. That is a strategy, and hence VL is one of the example. VL is one of the very much that's a variable assembly language and one of the example related to the first generation language. And later on second generation an advancement has been taking place because in, if the punched tape has been utilized continuously, if the once the punched tape has been utilized, the same dimensions will be getting progressed throughout the time period. But in the manufacturing range the dimensional accuracies will be getting deferred. They will be getting changed because some of the objects may be very much big in manufacturing, and some of the objects may be very much less in manufacturing, and some of them will be in a moderate strategy, etc. will be getting maintained. So for the such a kind, if once the puncture tape need to be characterized even for changing the dimensionals also, the next puncture tape need to be changed. So like that, each and every time the instruction set, so puncture tape in the sense here, the instruction set, that instruction set will be getting varied every time for commencement of the different kinds of activities. Next one it is that is overcome with respect to the second generation, because editing is not at all possible in the first generation, that is punched conditions, whereas in the second generation languages there is AML, there is or else VAL2, etc. And a structural programming language performing very complex kind of tasks, complex kind of tasks in the sense nothing but triangular or trusses type of situations, and counter positions. Counter positions are circular positions, and sinusoidal positions, zigzag positions, curvilinear positions, etc., which cannot be possible with respect to the n number of points can be monitored with respect to this particular structural programming languages. And apart from the straight line, interpolation performs complex motions also, just as we have discussed circular interpolation and sinusoidal spline kind of situations. These are all of the some of the examples. So these uses some of the forces, torque, and other sensors. Hence, indeed to guide or else to perform very quick actions, here additionally that indeed to maintain a particular force for commencement of the activity, particular torque for the rotation or movement, dynamical actions by the robotic linkages which are assembled here, and different types of other sensors also will be utilized for feedback accessing. So here implementation of sensors clearly specifies the system which is monitoring under closed loop control system. And next one is an data processing, file management, and keeping all the record system. And here, what is the defect that is being we have been observed in the punctured tape? If the punctured tape has been prepared, and similar punctured tape cannot be utilized for dimensional changed worked parts to be ut- utilized for manufacturing. But in the case of this programming, structural programming or interpolation performance in the second generation languages, a computer device will be utilized, and there the sequence of instructions will be getting existed. If furtherly, if we need to um, change the dimensions, just we can edit the program. And here the data processing in the sense whatever the program has been executed, that we will be sending to the machinery device in order to perform the certain actions related to the given program. And file management, so file management in the sense, for example, the same material has to be utilized and manufacture different toy cars the children will be getting played with them. So toy cars, XL shapes, so that will be manufactured within mini in size, maximum in size. So mini in size will be having 2.5 inches of width or 3 inches, and maximum in the sense that will be having of that 15 inches or 20 inches. So 3 inches will be occupying with some of the same program will have to be characterized because the shape of the car will be similar, but dimensions will be getting deferred. So within the 3 inches, we have to verify the dimensions that is only refer to 3 inches, and 25 inches or 20 inches, that dimensions will be getting changed. So the width changing in dimensions and axing of the wheel constructions, door settings, etc. will be getting changed. So beyond that, the editing will be getting done for the mini program which is already having a sequence of steps, and they can be changed from 3 inches to 20 inches, and reference coordinate axis also can be edited, and that program can be saved as a second profile, and that data can be sequenced for the actions that are being done, that can be done for execution level, for the execution level. So there is the greater advantage that the editing can be progressed in the case of second generation programming. And third level, it is an depending upon the feedback, appropriate decisions will be taking depending upon the task to be done. So in the case of this second generation we are having, the editings will be getting done for the existing program based on the given instructions. So if some of the editing has done, that has to be done by external person only. So there is no any self decisions that are being taking place. The sensors which will indicate that it's a wrong movement, that the machinery is commencing on the work part, that will be displayed. That's it. And that will be giving feedback by the sensors as an in the Sinton format, or else in the LED display, or else in the monitoring display screen that will be getting shown to the operating person. But whereas in the next generation, all modeling characterizations are task oriented, that entirely will be organized for all possible ways for commencing of that particular task will be identified based upon the analogy that are existing by the systemic device or standard module, which will be giving the access for the robot. And if there is any deviations that are being progressed, the deviations will be getting set right by the maximum device reference, and certain actions without any external support directly the system or control system will be accessing to the monitoring sections, nothing but processing devices in the sense different types of actuators which are existing with respect to the robot as an assembly device. And those kinds of actions can be progressed in the case of this world modeling and task oriented object level language. That is more advanced languages, world modeling and tightening of the nuts and looseness. Casually, we are seeing this in our mechanic sheds also by the electrical and utilization of pneumatic and hydraulic power supply. So basically, it will be acting as an electrical power supply, and when the solenoid has been energized, solenoid in the sense electrical power supply, that supply has been initiated, that supply will actuate the hydraulic or pneumatic strategy by operating this directional control valve, and that will guide the actuator to rotate towards the clockwise direction or counterclockwise direction as per the switches that has been given. Switches in the sense here the directional control valves that will be guiding with respect to the operator. So that is an additional advantage that the task will be getting commenced. So manually, if you've been tightening, it will take a large amount of time. But that systemic, that is electro-hydraulic or electro-pneumatic strategy will be calling. So if that conditions has been realized, it will be very much familiar. The task will be getting done within the least amount of time period, and hence intelligence is required for it. So intelligence in the sense commencementing or taking the self decisions. If any of the path is deviating is being taking place, automatically it has to be detected, and appropriate steps need to be characterized by the actuators directly for compensating the deviation, and next setting right of the proper guidelines. So here in this robot, there are three modes of operations in an global system level, or else the world modeling strategy. First one it is an monitoring mode. Second one it is an editing mode. Third one is an runner executing mode. We'll be having a detailed look beyond one by one. First one, monitoring mode. So programmer define locations, loading a particular information to the register and saving the profile, saving the entire programming, and it will be uh, stored in a storage device already, and that will be taken as a reference. So moving back and forth, editing or running mode can be conducted. So just as you have taken, when you have been entered the sequence of steps or series of steps, those will be saved in the form of a profile, and that profile will be utilized for editing sections, just as we have been discussed that dimensional changes, dimensions has to be increased in strategy. As example, we have been seen that 3 inches of car results in the 20 inches of the car manufacturing. So that modifications will be done in the coordinate axis towards the x, y, z, and beyond that, the speed, feed, and next depth of cut and type of the tools has to be utilized, type of the material has to be utilized. Those all or can be edited in the already saved program. So saved program will be retried back, and the modifications will be getting done over there, and then the same program will be getting starting the or running mode, in a running mode, nothing but execution level. So that program editing can be done here. Next, editing mode. Programmer, that's what we have been discussed. Can edit or change the set of instructions, and running or execution mode. So the predefined task can be executed, dry run can be tested, nothing but the edited program can be tested in the simulation strategy whether it is performing its task by the tool in a perfect strategy or not, whether you can achieve the output as per the vendor's decisions or vendor's requirements or not. Vendors in the sense the customer's requirement. The customer's requirement or not will be verifying. So that program will be debugging in the microprocessor. The processor will be getting in the fixed in the controller, and hence the controller will take care of the overall steps that can be progressed by the processor. Just we'll be having a detailed look regarding the sections that we have been utilizing or languages we have been discussed over here. Introduction to the VL, programming languages and operating systems which control a robotic system, which includes different programs, guides the routings for it for them also. So here routings and subroutines and multi subroutines indeed to move from the step 1 or else the point number 1 to n number of points, either in a connecting way or else in a separate way also can be captured in the case of this VAL systems. Uh, Representing the detailed transformations regarding the locations, nothing but representing its positions and orientation of the robotic tool. There are two ways. First one, it is an precision point or Cartesian coordinates and orientation angles. Nothing but precision points in the sense those are the perfect locations. Even by just like as we'll be utilizing that the locations in the sense as per the geotagging, north, latitudes, longitudes, etc. And next thing it is regarding the Cartesian coordinates, as we have been specified that Cartesian coordinates in the sense x-axis, y-axis, z-axis, and next theta orientation, inclinations, and next orientations towards the uh, clockwise revolution or the counterclockwise revolution. That also will be specified very much quickly, or that need to be specified in the case of this VL system for the commencement of different kinds of transformations. Either it may be the translations and retrieving motions, or else in the circular interpolations, or else in the rotatory conditions, or else to a particular inclination levels. Coming to the trajectory control, there are two methods for this trajectory control: finding out the best path, and next utilization of the that particular best path for traveling by the tool on the work part from the initial point to the ending point, final point. So that is interpolating between initial and final position, producing tooltip curve in a space. So as per the specified terminologies, that will be utilizing for its movement of the tool from the starting point to destination point. Moving that robot to tip in straight line path. So moving indeed to control strategy as per the given trajectory to the motion. If at all it is being deviating from the instruction set, the controller takes a major place by this particular tool to cut in an exact given dimensional strategies, right? Either it may be in an straight line path, or else the counter path, or else in the circular positions, whatever it may be as per the given programming. So the trajectory control in the first phase, the joint interpolated motion and the total time required for the longest joint in that particular robot will be analyzed initially, and in the second condition, the motion of the speed or robot tooltip, it can be accurately controlled. So accurately in the sense there will not be any tolerance variations also, even from the starting point to the ending point. So there will not be any deviations from the trajectory point while the performing its actions also. So how these can be considered? So indeed to commence these kind of actions, the monitoring commands which are giving to as an instruction set plays a major important role. That will be looking here. Monitoring commands. So defining and determining the locations, that is initial step and the final step, and the intermediate points which need to be characterized, or which the tool need to be passed through that particular points will be getting allocated, defined very much clearly. Second one, it is an editing of the programs. If at all the dimensions need to be changed, x comma y comma z values, or the geometrical values, or circular interpolation values, either in the theta level or else the phi level, those will be getting edited in the programming. And not only in the geometrical strategies, or else the movements towards the left, towards the right, or else towards the straight path, or towards the counter position, cylindrical positions, clockwise or counterclockwise, and theta with respect to positive axis and the negative axis, whatsoever it may be in the condition it is. Those also can be edited. So listing the programs and location data. So listing of the program. So here listing of the program in the sense different tasks of the programs will be deferred from one process to another process. That is what for milling will be having one program, drilling will be having one program, because the type of the tool will be utilizing in a separate strategy. Type of material will be different. Likewise, so for milling, it will be having a sequence of steps as in separate, drilling separate, reaming separate, boring separate, cutting separate, and exercising separate, etc. So those programs will be storing, and whenever it is necessary, they can be retrieved from the system storage and location data. And overall, these programs can be controlled within monitoring strategies. So determining and defining locations specifies that the point command, where the command is used to display the current location and guide the overall actions that is being done as per the given path in a recorded manner. Editing will be getting done based upon the commands, or else the geometrical calculations, or else the data as we have been discussing now. So the listing program and location data, the and storing of the commands by changing it, and whether it may be of an storing is that is repeated, storing is deleted, and storing commands can be reactivated in the list criteria, and loading conditions, unloading conditions, etc. of different load conditions, or those commands will be utilized for LOADP, LOADL. So loading, unloading. These are some of the commands. And for storing and retrieving, the commands that are being utilized are nothing but flist. Already that will be opening the overall programs that has been stored. And if at all the same program has to be edited, the conditions in the already programmed or saved program will be left as an common, and will be copying that and renaming to another strategy, and the modifications will be done on the copied programming, and if we need to save that, we'll be utilizing the save program, or else if at all the edited program is not necessary for us, we'll be deleting that particular program. Coming to the programming control, there are several possibilities for control or commands utilized for controlling strategy. That is speed control, executing commanding control, control, abort command, and driving command, and align command. So aligning in the sense joining of the two different route maps. Programming instructions. So describing the programming instructions is an most important characteristics in the programming. First one is an robot configurations and motion control, hand control, location, assignment and modification, and finally the program which has been edited or else the entrapped that need to be controlled. And initially the commands which are existing in the configuration control will be having, that is right y, and towards the y axis direction in the straight line path movement right y. So that indicates that the tool to be moved in the right side direction towards the y axis or towards the left y, or these can be nominated as an above or below. So above in the sense it is positive y-axis towards 25 mm, in the sense nothing but we are already having this is the reference line. So positive in the sense, for example, if you can see 0 here, positive will be here, and negative in the sense beyond the line. If this is the 0 line, negative will be in the below line. So those are the commands. Next, motion control in the sense this will be having some of the commands, that is moving towards the right, moving towards the left, and move command, drawing command, and appropriative conditions and approximation conditions, and circle, spline. Already default systems that are being realized. Only the radius can be specified, and depending upon that, the interpolations will be getting done. So those will be coming under the motion control commands. Next one, hand control commands. There is nothing but pressing of the switches or else the opening manually the door or else the work part which is already fixed in the chunk. So if you have been opened that manually, that will be coming out. That is what part after completion of the processes will be coming out. And after replacing the new raw material for processing, again chunk will be getting tightened. So for that, open, close, and that will be releasing in our characterizations or command utilized for automatical strategy. That's open I and close E, close I commands. That, right, that will be utilizing in the VAL2 programming. Nothing but a gripper closing command given by the grasp 20, 15. So it indicates that the gripper which is grasping, gripper in the sense nothing but the chunk which is getting fixed or tightening the work part, because if you have not yet been tightened, when the tool is being in a work mode, the work part will be in different creates different vibrations. So that vibrations leads to the non appropriate dimensions characterizations in the work part. So exact dimensions upon manufacturing will not be getting obtained. So the hand control, so moves move start part as respect to 30. So that is nothing but until the 30 centimeters or 30 mm, the straight line path will be getting moved by the gripping axis or by the tool at the gripping axis. Next one, hand control, move teeth part, is through the part. It causes the gripper to move the position part within the opening of 30 mm by the joint interpolated motion. So nothing but up to the 30 point. Before condition it is move ST, nothing but starting part of the 30, nothing but 29 up to completion of 29, it will be getting moved. 30 it will not be getting entered by this particular instruction. Move ST, but move T part. So move T part in the sense exactly at the 30, at the middle strategy, it will be the tool will be positioned. Next one, specifying of the location, alignment, and modification. So these are the instructions to the same corresponding monitors towards the setting and here commands. Here, the programming control will be saying towards the programming control commands. Setting I, nothing but it gives the value of an integer value to result of an expression. 9, similar to 8, type I displays that name, what type of name or process that is being considering, and what is the value of the integer. So value of the integer in the sense as we have been specified before, that is mini toy manufacturing or maximum toy manufacturing. For that we'll be having mini typing in the sense here displays the name. So mini toy of 3 inches, so that can be typed with respect to an alphabetical characterizations, and simultaneously in the large strategy also, so 30 likewise, and later on go to 20. Next go subtraction and return and pausing conditions. These are some of the commands utilized for halting temporarily the process, and goes up process in the sense up to the subtraction or sublimitation the program or tool will be getting moved on the work part, and returning conditions. So after completion of the program again the process will be reinitiated to the starting point, that is returning condition without commencing. Ideally it has to be moved, or else then if there is any further actions that need to be considered in the reverse direction also will be identified. So here go to specifies that without disturbing the rest of the parts directly it will be moving on until the 20 dimension is being obtained. Either it may be towards the x, positive x or negative x, positive y or negative y, or positive z or negative z. And coming to the point of this programming control, so controlling specifies different actions that commencement of activity in the sense it leads towards the proceeding, and signal. So signal specifies that either positive signal or negative signal for commencing of the activity in the forward direction or else the reverse directions, or if signature. So if signature in the sense if the condition given to that particular signature in the sense commencement. So if the condition as per the given strategy is satisfied, then only the signature will be considered. Signature here in the sense commencement of the activity, or else it will be getting in wait mode until the external support has been given, or else the condition has been satisfied in the programming. So next one, resetting. So already executing program has to be halted immediately and resetting. Resetting in the sense if there is any modifications have been done in the programming, and if you are running that editings all will be getting deleted in the case of this reset. And originally at the first time whatever you have been given as an input dumping, the only that programming will be getting into the accessing, that will be coming under the reset. So complete default sections, that primarily what the values in the programming that you are giving, or what are the set of instructions that you are feeding, only that will be coming into the sections. So coming to these are the some of the overall strategies, and coming to the economic point of view, economics point of view, a simple economic analysis assumes the playback period. As per the given formulation, we can identify that a playback period or payback period is equal to R by, that is an returning strategy or reading by L minus M. So here investment relates towards the R, and L towards the labor saving per year, and M refers to the maintenance and programming cost per year. Here the P is an payback period in years, considering for about 1 year or 2 years, etc. And R is nothing but the investment in robot and accessories. L is the labor saving per year, and M is the maintenance and programming cost per year. So by this formulation, we'll be identifying or analyzing either by an assumption or else the overall payback period by the given formulation. We can calculate the task and what are the maintenance certain actions that are being performed, and for the input it is being in uncontrollable limitations or not. We can have a clear cut vision whether we are getting in a profit or else in a loss strategy. Whether the company or else this robot operating is coming in a positive economical ratio or else negative economical ratio can be identified very much clearly. For this, wherever these actions are being utilized, moving for the different kinds of applications as we've been discussed previously, that in an automotive industry it has been utilized, and the programming, if a programming has been given into it, there's many further monitoring actions that are required until the program has been completed, unless and until if it is in closely control system, if any malfunctioning has been taken place, the feedback signal will be given by the highlighter indeed to give the external support for the system until and unless that signal has been given. Straight away the program will be getting executed, certain task will be getting performed, and corresponding output also will be getting obtained. So that is the automotive industry. In the assembly conditions, nothing but joining of the different types of parts and constituting as a major component. Nothing but, for example, if you even consider the car, will be having steering and the 8 wheels, chair. There is nothing but the internal seats, accelerator, and the engine, wheels, etc. So those will be getting aligned, and then assembly conditions for tightening. Overall, these also the programming will be getting utilized for the robot, and that particular robot will take care of necessary fittings for a number of components to a single constituent of component. Next one, medical laboratories. And the medical laboratories also, where the manually the actions cannot be considered later on at that particular positions. This robotics plays a major important for exact mixing. That is what composition. For example, if we are considered in the medical strategies, we will be having in the tablets also. Sheet backside, if you have been taken have a look at the composition, you'll be finding that calcium 5%, 0.5 percentage, fat 0.5 percentage, sodium 2.5%, likewise, vice versa. So the composition also can be identified by this robot in perfect strategy, even in the milligrams also, micrograms also, likewise these robots plays a major important role. So this blending operations in the as per the composition basis, and the packing sections, and the transportation sections or storing in the warehouse sections also can be performed by these robots. And these robots can be placed in a different conditional strategies in the medical laboratories and even in the medicine manufacturing, as we have been discussing about the composition level, and even in the nuclear energy. So in the nuclear energy, in the sense at this, the compositions or chemical reactions will be taking place at large temperature strategies or else the minus temperature strategies, where the manual involvement is not at all possible. At that particular situations, this robotics will be utilized. So these are the applications regarding it. And even in different agricultural process for fluffing and remove the obtained crop, and storings, and grain removal for it, and separating the particular grains and polishing levels, etc. And spatial exploration, underwater inspection, customer service, and arts and environment, etc. There's some of the applications regarding the programming strategies in the robotics. So final conclusion is nothing but the robotic began as a form of entertainment and has evolved into a technology used in n number of fields, which increases in its production and endurance, and even by that number of components can be manufactured in a high quantity and with a perfect quality maintenance. And also different jobs which require very much speed, accuracy, extremely boring reliability, or endurance can be performed far better when robotic than the human. So finally, there is a conclusion by the utilization of this particular robots without any human involvement. Entire the task will be getting done in a perfect accuracy strategy, right? Conditions. Thank you.